and explain in the ROS1 3 robot simulation and to simulate it in the Gazebo and RViz. Okay. Basically, here you can see we have simulation where in RViz I've added drilled, robot model as well as TF, where you can see how the movement has been captured as well as in the Gazebo, how it is being currently moved. Okay. I will be explaining now just the structure, what it would require, what are the files that we would require to do, okay, to set it up. First and foremost, we require to have ROS1 installed. You can click mkdir the catkin WS, okay. After that, we require certain packages to be installed. So you can use catkin underscore create underscore pkg with package name. Like first would be the file name, folder name, that would be trivial robots with roscpp, rospy, sp message, and Gazebo ROS. Okay. Then inside, once you hit that, you will be able to see this kind of folder structure. First, you require to create, I would say, two files. That one would be for the Gazebo simulation launch file, another would be for RViz simulation. URDF file. URDF file is more like a file that contains actual um, macro, okay, on which we will basically define each of the geometry collision, which are all the wheels which are there, what are linked to what, which one, and so on. Okay. Apart from that, I think we don't have to change anything on this packages or simulation. I think that would be all good to go. We already have predefined one that will store it up. We just need to, when we install, we need to ensure that we then create the package with this files. So once we do that, we don't require to do anything on that. Okay. I'll just explain the macro first. Okay. This is our base link URL. Base of the robot. Okay. With what color it has to be, what would be the collision power, what will be the initial movement of it. Okay. Then comes the left wheel in the same fashion. Left wheel, we have with what would be the collision, what would be its initial, and the joint name. Okay. So base link is connected to the left wheel with what origin values and what axis value. The same will happen with the right wheel. Okay. Where in the right wheel, we explain the where it visualize what would be the collision value, initial value, and what it would be linked to. Okay. Most parent would be, we can see here, base link, on which both would be connected. This is the third one. That would be the third wheel of it. I initially put a caster wheel, which was earlier I tried with fixed one. Okay. More like running like a what we call it, horse, but I made it to continuous with certain values so that it can be moved much more smoothly. Okay. And this is these are the publisher values that we require for the left, right, okay, to be performed out. Okay. When it comes to explain, this is on the this I explain everything on the macro side. Okay. This is a launch file. Launch file is just talking about first which macro that needs to be executed on the launch simulator, okay, with what would be my URDF file where it is actually presented. Okay. Same thing what we have done for this one. This is for Gazebo one. Okay. So find Gazebo ROS. Okay. In the same way, if you require for the RViz, okay, we require to do find the we need to create the RViz file for it. Okay, by using RViz package for it. Running the simulation is also pretty straight. I will just terminate few of those things so that everyone can see out of there. Okay. So this is the command launch third wheel launch with 3 wheel launch. Okay, once I execute it, quickly open the terminal with third 3 wheel into it. Okay. I also have certain values. Okay. This is ROS topic where you pass the initial linear motion to it. Okay. As well as angular with what value. Once you do that, you can see it has started moving. Okay. If you require to visualize it into the RViz as well. You can see here that I'm launching the RViz file. Okay. Once you do that, a simulation will turn on. Okay. Currently, you can see here the global fixes error. What you can do is change it to odometer. Okay. Once you do that, your odometer has been fixed. You require to add two things. One would be the robot model. Okay. So that you can start seeing the robot inside this one. And then you can also add your PF if you require to be. That will help you understand of what was the initial point and where it is currently over here. That is it. Thank you. Bye.